Hello everyone. Today we'll be doing the memory management case of the first fit. So in first fit case of memory management, the process is allocated to the memory block, which is having the size greater than that of the process, and it does not need to recheck or loop through the entire process. So whichever first memory block satisfies it, the condition, it allocates that process to that particular memory block. So it does not care much about the internal fragmentation or whether the process is best suited or worse suited. So it finds the first suited process memory block for that process. So here I've allocated hard-coded the values of the memory block array, and the length of the array is found using this size of the memory block, entire memory block array, divided by size of each memory block of that array. And we have taken another array in which where we have hard-coded the values of the process, and we have found the length of the array using the size of function as in the similar way as done in the memory block. We have dynamically allocated and initialized the array allocation that which is having the size that of the process m, where we'll be reinitializing the value of allocation with that particular index where the with that particular index and block where that process is allocated of. We are talking about the memory block basically. So we have already initialized it with -1 in case block which does not satisfy the process, or in case there is a process which is having a size greater than that of the memory block, and any of the memory block is not able to satisfy it. So first of all, we'll loop through each and every process. We'll do the first index with -1 every time for a new process. We'll loop through the entire array, and it finds if the memory block is having a size greater than that of the process. If the first index is -1, which was, if it satisfies the condition, the first one case only, we don't need to worry much about further checking. So if the first index is -1, which obviously it will be for the first case only, for the first time, for every process, the first index will be -1. So it will come down and it will initialize the first index with the value where the memory block is satisfying the condition, that particular index of that memory block. So let's see with an example for 212. It checks whether 100 is satisfying the condition. M100 is not greater than the process. It goes further. 500, yes, it satisfies. 500 is greater than that of the process. Uh, 212. So it comes down. First index is -1. Yes, we had already initialized the first index to be -1. So it comes down. It initializes the first index with the value of 1 for 500 for the process 212. And it comes down. The first index is -1. Is not -1, then allocation of that process will be done that with the first index, which is 1 for 500. So process 200 is allocated to the memory block 500, which is the first one suited. Memory left is 288. We will be reusing this memory here according to this code I've generated. So the 212 process is allocated to the block number 2. So this is the block 2, this is block 1. So for 417, it goes and checks. This is now 388, 288. So obviously it will not satisfy. This will not satisfy. This will not satisfy. This will not satisfy. It goes till 600. It incrementing the value of j. Memory block 600 satisfied comes down. First index is obviously -1 because as we have incremented the value of I, we have reinitialized the first index to be -1 now. So for every process, first time the process first index will be -1. So it satisfies the 600 satisfies this condition, comes down. First index is changed with the value of 4, 0, 1, 2, 3, and 4, fourth. It comes down, initialize the allocation array. So process 417 is allocated to the memory block 600 and the memory left is 183. Now it will check for 112. This is 100. This is uh, 288. So yes, it satisfies. 288 is greater than 112. It comes down. First index is -1. Every time the process is changed, first index is changed to -1. First index for this particular process is now changed with the index of the value. This is 288. So this is 1. So this is block number 2, J. So allocation is done. Process 112 is allocated to the memory block 288. Memory left is 176. Now for this process 426, this is 100. This is now after changing from 288, it is now changed to 176. further minusing and subtracting the value. This is 200 not satisfying, 300 not satisfying. This is not 600. This is now 183. So for the process 426, none of the memory block is capable of taking this value, as every memory block is having the value lesser than that of 426. So already, as I told, allocation at that particular index is already done with -1. So the allocation is done with the first index, and the first index remains to be -1, as while looping through the memory blocks, none of as while looping through this condition, none of the memory block was able to satisfy this condition that the memory block is greater than that of the process. So the process is not allocated any of the memory. So for the fourth process, 426, none of the block is allocated, which I have done here. If the allocation at that particular index is -1, not -1, then show it with that particular. Then show it with that particular block, otherwise write not allocated. So this is the entire uh, output of the first fit, and this is the code for first fit. Thank you so much.